Today we will discuss Aufbau's principle. Aufbau is not the name of a scientist, it is a German word meaning building up. According to this principle, the vacant subshell having lowest energy, the vacant subshell having lowest energy is filled first. When this subshell is filled, completely, then filling of next subshell with higher energy starts. For this, it is necessary to draw energy level diagram. Energy level diagram is we can draw energy level diagram like this. Now in these circles, name of subshell is written like this: 5s, 6s, then 7s. In second row, 2p, 3p, 4p, 5p, 6p, then 7p. In third row, 3d, 4d, 5d, 6d. In fourth row, 4f, then 5f. We can draw lines like this. Now, on the basis of these arrows, we can write increasing order of energy of subshells. First of all, energy of 1s is lowest, then 2s, then 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, then 6s, 4f, 5d, 6p, 7s, 5f, 6d, then 7p. This is the increasing order of energy of subshell. So first of all, electrons come in 1s, then 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, then 7p. On this basis, we can write configuration of some elements like 1h. 1 is 1 because one electron is present in hydrogen. 2He, helium. 1 is 2. 3, lithium. Then 1 is 2, 2 is 1. 4, beryllium. 1 is 2, 2 is 2. 5, boron. 1 is 2, 2 is 2. Then after 2 is 2p1. 6, carbon. 1 is 2, 2 is 2, 2p2. 7n, nitrogen. 1 is 2, 2 is 2, 2p3. 8, oxygen. 1 is 2, 2 is 2, 2p4. 9f, fluorine. 1 is 2, 2 is 2, 2p5. 10, neon. 2p6. Now, next electron comes in 3s. 11, sodium. 1 is 2, 2 is 2, 2p6, 3s1. 12 mg. Similar, then 3s2. 13, aluminium. 3s2. After 3s, 3p1. 14, silicon. 3s2, 3p2. 15p. 3s2, 3p3. There are some exceptions also. 24, Cl, chromium. According to Aufbau rule, configuration of chromium is 1 is to 2 is to 2p6, 3 is to 3p6, 4 is to 3d4. But it is wrong. Correct configuration of chromium is 1 is to 2 is to 2p6, 3 is to 3p6, 4 is 1, 3d10, 3d5, sorry, 3d5. This configuration is correct because d orbital is half filled. In this case, 5 electrons are present in 3D. According to Hund, half-filled and full-filled orbitals are more stable. So, this is more stable configuration. So, it is correct configuration of chromium. Similarly, 29 copper, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. One electron from 4s jumps to 3d. It is correct configuration of copper. 41 NB. 1 is to 2 is to 2p6, 3 is to 3p6, 4 is to 3d10, 4p6, 5s1, 4d4. This configuration is correct. In the case of 42 molybdenum, similar like NB, but there is one difference, 4d5. 46 PD, palladium. In this case, 5 is 0, 4d10. 47 Ag. 5 is 1, 4d10. 78 platinum. 1 is 2, 2 is 2, 2p6, 3 is 2, 3p6, 4 is 2, 3d10, 4p6, 5 is 2, 4d10, 5p6, 6s1, 4f14, 5d9. 79 gold AU. Similar configuration like PT, but there is a change, 6s1, 4f14, 5d10. So be careful when you make configuration of these exceptions. Now, configuration of ions. If we want to draw the configuration of Na plus, then first of all, number of electrons present in Na plus. Atomic number of sodium is 1, minus 1 due to positive charge. Then 10 electrons are present in Na plus. So configuration of Na plus is 1 is to 2 is to 2p6. O 2 minus. Anions are formed by gaining electron and cations are formed by losing electron. Number of electrons present in O2 minus. 8 electrons are present in O plus 2 because anions are formed by gaining electron. So 10 electrons are present in oxide ion O2 minus. Configuration of O2 minus is 1s2, 2s2, 2p6. But in the case of D block elements, when electrons are present in D subshell, suppose Cr 24 Cr plus Cr3 plus. We want to draw configuration of these three, chromium ion and Cr plus and Cr3 plus. In the case of chromium, 1s2, 2s2, 2p6, 3s2, 3p6, 4 and 4s1, 3d5. This is the correct configuration of chromium. Cr plus, in Cr plus 23 electrons are present. But in the configuration of D block elements, one thing is to remember. First of all, electrons are removed from Ns, then N minus 1d. Ns means S subshell of outermost shell. N minus 1d means D subshell of penultimate shell. Penultimate means, suppose N is 4, then N minus 1 is 3d. 3d, 4 is 3d. In the case of Cr plus, the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, because first of all electrons are removed from Ns, outermost shell. In the case of Cr3 plus, 4s0, then 3d3. Similarly, in the case of copper, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. It is also D block element. In the case of cuprous ion, one electron is removed from 4s. So it becomes 4s0, then 3d10. Cu2 plus cupric ion, 4s0, 3d9. Similarly, in the case of Ag, silver, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1, 4d10. Ag plus 5s0, 4d10. If you want a video tutorial on any specific topic of chemistry, please comment below. If you like this video, then like, share, comment and subscribe this video. For more details on chemistry, please visit our site chemistryonline.com. Thank you.